All right, so today we're just going to continue to do what we've been doing. We're just going to work on solving triangles. So to solve a triangle, we're going to do the angles. So we have alpha, we have beta, and then we have gamma. Gamma will always be 90 degrees. Okay. Then we have the corresponding sides. We have A, we have lowercase b, and we have C. Now, C is always the hypotenuse. Well, actually, you know what? They really screwed up everything. I don't like the textbook. So take this in your notes and just scribble this out. Call that C. Okay. Then they use theta. Oh my gosh, everything's wrong. Well, I should probably look at the problem before I start writing stuff down. So we'll call this gamma. 90 degrees. Okay. And I'm going to call A, we'll call this A, and we'll call this B. So A is 8.83, B is 1.83, and then we don't know what C is. We don't know what alpha is, and we don't know what beta is. So probably we'll have to come back and find theta and beta based on the ones that's given to us. So what I'm going to do, and I want to stress this, the given values are what we want to use to calculate everything. Sometimes students will do this thing where they go, oh, I know what this is. In other words, we're going to find out what C is, what the length of C is, and then we'll go, oh, I can find alpha because I know what the hypotenuse is. But what if I make a mistake when I calculate the hypotenuse? So those are the things we always want to, when we go to calculate the sides and the angles, we always want to use the values that are given to us, okay? So keep that in mind. And then also, there's some common sense checks, but we'll talk about that later. By the way, how many significant digits do you see up there? 3 over here, right? Now this 90 is not necessarily given to us. So probably 3 digits would be good. So we're going to say 3 significant digits. 3 sig digs. So that's probably what we'll do with our it's usually the lower of the two. In other words, I could say that this is 90.0 or something, and that wasn't given to us. I just wrote it down because I know that I know that theta plus beta has to equal 90. So the first thing I'm going to do is I'm going to solve for C. So remember, to solve for C, we do the Pythagorean identity, which is a squared plus b squared equals c squared. So that means I'm going to say 8.83 squared plus 1.83 squared is going to equal c squared. Now, on your handy-dandy calculator, you could do that in one swoop. So if I say 8.83, hit the square button, boop, plus 1.83 squared, right? Bloop. And I get an answer which is 81.31 something something something. So I'm going to see that this is 81.3178. Is that what you guys got, roughly? Now, we don't worry about the significant digits until we get to our final answer. So it's always better to keep all of don't round at the beginning, round at the end. Well, that equals c squared. Okay, cool. Well, what do I do next to find out the length of C? Take the square root, right? So I'm going to take the square root. By the way, what's 9 squared? 81. So we should have a value a little bit bigger than 9, right? Does that make sense? So if I make a mistake, I can oops. So I'm going to take the square root of 81.3178. This is so hard because I can't see it. Oh, I'm hitting the wrong thing. That's why. Let's take the square root of 81.3178. Is that right? Yeah. It's kind of hard to see on my calculator. So we'll really zoom in on it. Oh, we can't. Okay. Yeah, this is worthless. So I hit enter. And I get a 9. I get approximately, well, let me write down what I have. I have 9017638, and this goes on and on and on, equals C. So what I want to do is I'm going to round this to 3 significant digits. So this would actually become 9.02. Okay? Feet. I should probably mention all of these are going to have the unit of feet. And that seems reasonable, right? The hypotenuse is always going to be the longest side on the triangle. It is the longest among the 3. So now let's go back and find alpha and beta. Well, remember that if I solve for alpha, so let's do it this way, or not alpha, I'm sorry, theta. This is theta. So this angle over here for theta is the opposite, and this side is the opposite, and this side is the adjacent. What trig function is the opposite over the adjacent? Tangent, right? So remember, SOHCAHTOA. So sine is the opposite over the hypotenuse, ka. Cosine is the adjacent over the hypotenuse, and toa, tangent is the opposite over the adjacent. So way over here on the side, I'm going to say tangent of theta is equal to the opposite, which is 8.83, all over the adjacent of theta, which is 1.83. Then I'm going to take the inverse of both sides, so I'll end up with that theta is tan inverse of 1.883 divided by 1.83. And I'm just going to do this on a calculator because you can't see my screen, which is unfortunate. So remember, to find the inverse functions, I'm going to hit that. And then I'm going to go back here, and it was 8.83 divided by 1.83. Close the parentheses. Oops. No. There you go. So I've got 78.29. What are the significant digits we're using on this bad boy? 3. So what do I round this to? 78.3. So I'm going to say theta is 78.3. Now you could go, here's the interesting thing. You could go and do the exact same thing for beta, but you might get a rounding error. So when it goes to finding the angles, we just want to make sure they add up to 180. So remember that theta plus beta should add up to 90, right? So then if I know what theta is, which is 78.3 plus beta equals 90, then we know that beta will equal 90 minus 78.3. So again, I'm going to say 90 minus 78.3. So I'll say 90 minus 78.3. 11.7. All right. Any questions on that? No? Okay. I'll leave that up there for